So in this case, we are going to move on considering determinants, working with the determinant of a 2 by 2 matrix. So we can obtain or have calculations on the determinant if we are to consider the formula. Let's say we are given matrix A is given as A, B, C, D. This is a 2 by 2 matrix. So we can determine the determinant of that 2 by 2 matrix by using the formula. All right, so this indication here is for determinant, or you can write these presentations for determinant of A, determinant of A in short like this, or this one. All right, it represents what? The determinant of a certain matrix. It is given by taking the product of the major diagonal A and D. This diagonal is referred to as the major diagonal. All right, the major diagonal. So you take that major diagonal as a product. So it is the product of the major diagonal minus the product of the minor diagonal. So B and C, this diagonal, this one. Remember, we said it is a rectangular form. So you say this is the major diagonal and this one a minor diagonal. All right. So that is what you're considering. So that is BC. So this is the formula, product of major diagonal. All right, so let me just write here, product of major diagonal minus the product of what? Minor diagonal. So that is the concept. This is our minor diagonal. So when we are given this, we can determine the determinant of any 2 by 2 matrix. So given this condition or working with this, let's say we are given, for an example, matrix A being a 2 by 2 matrix, all right? 3, 4, 1, 7. And from that, you're asked to find the determinant of A like this, or determinant A, or determinant, all right, or determinant of what? Of A, from the question that you're given. How do we determine that determinant? So this is our determinant, the product of the major diagonal. You multiply what is in the major diagonal, AD. This is your major diagonal, 3 and what? 7. So 3 times 7 together. You subtract what is in the minor diagonal. The minor diagonal is the 4 and the what? The 4 and the 1. So you take this 4 and 1. That is your minor diagonal. 4 times what? 4 times 1, our BC. So that is it. So simply multiply and evaluate. 3 times 7, that is 21, minus 4 times 1, which is what? Which is 4. Then we subtract 21 minus 4, that is what? 17. So our determinant is what? 17. So that's how we simply play around with the determinant. You simply need to consider, all right, the diagonals and these directed numbers in the simplification, all right? Given matrix B, which is given as -1, -3, 2, 4, like this. Then from that, you're asked to find the determinant of what? Matrix B. So determinant of matrix B, as before, the product of what? The major diagonal, -1 versus what? -1 versus 4, minus the product of what? The minor diagonal, 3 versus what? 3 minus 3 versus 2. So that's -3 versus what? Versus 2. So that is the determinant of what? Matrix B. So -1 times 4, that's -4. We subtract. What are we subtracting? -3 times 2, which is what? -6. So take note, we've got a minus and a minus. So that is going to give us what? A positive. -4 plus 6, which is simply means what? Which simply means 6 minus 4. So 6 minus 4, that's 2. So that's the determinant of what? Matrix B that you have obtained. And the first one here, it was what? The determinant of what? Matrix A. So that is the consideration. So when you have to consider now these matrices that we are obtaining a certain value for this determinant, it's -1, it's 17, and so forth. Those matrices are called non-singular. They are non-singular matrices that we are having, where the determinant is not equal to what? Is not equal to 0. When the determinant is not equal to 0, those are non-singular. We have a condition when it is what? A singular matrix. Now, when it is a singular matrix, it is the one whose determinant is going to give us what? Is going to give us a 0. When that happens, it is a singular matrix. If you were to find the determinant of this matrix, all right, the determinant of this matrix was going to be the product of the major diagonal. What is in the major diagonal? 2 times what? 3. Minus what is in the minor diagonal, which is 6 versus what? Which is 6 versus 1. 6 and what? 6 and 1 in the minor diagonal, 6 times 1. So this is what you're going to have. 2 times 3, that's 6 minus 6, which is what? Which is a 0. So thus, determinant giving us a 0 alone tells us that we are dealing with a singular matrix. So those matrices whose determinant is 0 are referred to as what? Singular. And the non-singular are the ones that we can obtain the determinant which is not equal to what? Which is not equal to 0. So on a singular matrix here, we are saying what? Determinant equals to what? Is equal to 0 for a singular matrix. So we are going to talk about that later on the inverses. That is why we see on the inverse matrix, when we are to find or you and also use the inverse of a 2 by 2 non-singular matrix. Why? Because a singular matrix do not have a determinant. I mean, they have a determinant which is 0. So we say we do not have the inverse later on, but the determinant is what? The determinant is a 0. So that is another application that can also be used in calculations. You know, guys, for exam, they'll be just playing around with you, given, let's say, for an example, we are given matrix A is equal to 6, 1, then this is 3, and this is X, all right? Then you are given this, find the value of what? Find the value of X if A is a singular, or is what? Singular. If A is singular, something like that, all right? So they will give you something like this. Given matrix A being a 2 by 2 matrix, find the value of X. If A is singular, for a singular matrix, determinant is 0. So you just consider to say, for this to be what? To be singular, the determinant of matrix A has to be equal to 0. So I simply consider, as I was calculating that determinant, the product of the major diagonal, 6 times what? 6 times X, minus the product of the minor diagonal, which is 1 versus what? 1 versus 3. 1 times 3. 1 times 3. I'm supposed to obtain 0 as my answer. So I have formed an equation which I'm supposed to use and solve for what? Solve for X. All right, so let us solve for x. 6 times x, that is 6x. Minus 1, all right, minus, yes, sorry, yes, 1 times 3, which is what? Which is 3, but there is a negative, so it's just going to be negative 3, and that's equal to 0. In this equation that you have formed, it is a linear equation. Check on your equations. Under the playlist of equations, you can see this type of an equation is what? A linear. The highest power on x is what? 1. That's a linear equation, so you simply need to take the minus 3 to the other side of the equation. Is going to be a positive 3. It was a negative. Divide by 6. Since we have a multiplication here, you divide to obtain the value of what? The value of x. So 3 into 3, that's 1. Into 6, that's a 2. So that is going to give us 1 over what? 1 over 2. So that's the value of x that will make that matrix to be singular. The determinant will be equal to what? Will be equal to 0. If you use that value, if you put that value of x here, which is 1 over 2 that we calculated here, and we have this as what? 1 over 2, and find the determinant, it is going to give you a 0. So that is, they can ask the question in this manner. If you are told that it is singular, you use that concept. Do not use it when you are not told, guys. When the statement is singular matrix or has no inverse, because we are going to talk about that for a matrix that has no inverse. The singular matrix, this one, has no what? Has no inverse. So when they state that there is no inverse, you can as well use the same concept of what? The singular matrix, which is the determinant being equal to what? To 0. All right, so that is it, guys. It's all about revision. Let us do revise as many questions as we can. Shall meet again for the inverse of a 2 by 2 matrix in the next class.